Just a little side note, you guys all have a download link to this slide deck. I would definitely encourage you, if you have not already, to pull down a copy of this slide deck. On just about every single slide in this deck that we're going to run through, I've tried to put some additional information, links you can follow, maybe ways to get hands-on or learn more about the topic down in the notes section of each slide. So there's really some good information in there. I would highly encourage you to pull down this slide deck. And if we start talking about interesting topics, something you want to know more about, something you want to dive in a little bit deeper on, or something like that, check the notes on the slide. Chances are there are going to be a few links in there where you can go and you can learn some more. And if there aren't, please feel free to reach out, ask us questions anytime. We're always here to help provide any insight or answers we can on anything blockchain related. So, like I said, thanks again for joining us, and let's go ahead and dive in, shall we? So to get everyone on the same page, let's just start by defining some common terms that you hear a lot in the blockchain world. If you're just getting into blockchain, you're probably hearing a lot about immutable append-only ledgers that are managed by group consensus. Well, let's just pause for a minute and talk about what some of these terms mean. So when we talk about something that is immutable, we're talking about something that can't be changed, it can't be edited, it's permanent. Once it's created, it's there for good. You'll oftentimes hear people describe blockchain as a globally shared database. And I always tell people that's an adequate explanation as long as you keep in mind one big difference, and that is that databases have 4 primary functions. They can create data, they can read data, they can update data, and they can delete data. In the blockchain world, we intentionally remove those last 2 options. All we can do is create or read. There is no update. There is no delete. And that's what makes our ledger immutable, because we can't go update anything or edit anything, because we can't delete anything. Everything we put on there is permanent. And that leads to its append-only nature. If we want to add more data to the ledger, we simply append it to the bottom. And this is how we manage update and delete scenarios in the blockchain world. If we have a record and that record is updated, well, we don't update the record in place. We append a new record to the bottom of the ledger, indicating the new state, communicating what's changed. Similarly, if we have a record that we want to delete that's no longer valid, that should no longer be considered, we don't actually delete it. We simply append another record to the end of the ledger, indicating that that data point is no longer valid or should no longer be considered. When we talk about a ledger, I know, at least in my mind, when I was first coming up to speed on blockchain, the word ledger, I had this very, very strong association with financial records or accounting records. But really, in blockchain, when we talk about a ledger, we're just talking about any kind of historical log. We're just keeping a history of something. That may be the history of financial data or assets. It may be the history of something completely different. But a ledger isn't showing us just a snapshot in time. It's not just showing us the current state. It's showing us a history. And then finally, consensus. This is a very, very big idea in blockchain. This is just the idea that in blockchain, we're going to assume that the truth is whatever the majority of participants believe that it is. And this is this idea of consensus. So if we have a clear majority in our network that all shares a certain outcome from a transaction, well, that's what we're going to assume the truth to be. So when we talk about blockchain, we're talking about a ledger, a historical log, which is immutable. It cannot be changed. Because it's immutable, it's append only. We can only add data to it. This ledger is stored many, many times. There are many redundant copies stored across the network. And each of the nodes managing each one of these individual copies attempts to stay in sync with every other node using this idea of group consensus. If you're just new to blockchain and these terms are relatively new, check the notes on this slide. There's some really good links in there, including links to 2 absolutely 100% free classes that you can take to get up to speed if you're just new to blockchain. Well, in order to really understand Hyperledger, especially Fabric, and some of the architecture decisions that were made when Fabric was being designed and developed, I think it's important to understand a little bit of blockchain history and where Fabric fits into the overall timeline and series of offerings. So if we go way back to the beginning of blockchain, 10 years ago, we have the world's very first blockchain, the one that most people are most familiar with, the one we hear about the most, and that is Bitcoin. Bitcoin was a blockchain that started 10 years ago back in 2009. And the Bitcoin blockchain, the ledger that we have on Bitcoin, is used to track the history of just one asset, and that is Bitcoin itself. So on the Bitcoin blockchain, we use that ledger simply to record and to track the trade and exchange of Bitcoin. We only have a single shared ledger. There is only one ledger in Bitcoin. And this is by design. We want everybody in the world to be using that one ledger because if I was trading Bitcoin on my ledger and you were also trading Bitcoin on your ledger, how do we reconcile with each other? It becomes very, very difficult. So by design, there's just one single shared ledger that the whole world shares. And Bitcoin is what is oftentimes referred to as a blockchain 1.0 platform. It's a first generation platform. Excuse me. And these are characterized by the fact that they're really just a ledger. There really isn't additional functionality. They're just there to capture data. So in the Bitcoin world, we're just using that ledger to record data, to capture information about the exchange of Bitcoin back and forth. But by and large, we're not adding our own logic into the blockchain. We're not writing any code. We're not embedding any business logic. We are simply using the ledger or the blockchain as a way to record data. Some other interesting things about Bitcoin: it's anonymous. We don't have any sense of identity. We don't know who our users are. Our users are by design very highly anonymous. And so this means that all of the data on the Bitcoin blockchain is fully transparent, because if I don't know who you are, if users don't have an identity, well, then there are only 2 choices. And that is, we either elect to show nothing to anybody ever, or we show everything to everybody all of the time. And that is the option that Bitcoin is elected to go with. And really, the primary focus of Bitcoin is to create a platform and a ledger that enables and facilitates digital payments and the transaction of digital currencies. So you can go to a site like blockchain.info. That's where I got this screenshot. And you can go out and you can view a Bitcoin transaction. So here's an actual Bitcoin transaction. And you can see that this wallet or account sent some funds to this other wallet or account. We can see how much was sent, just a little less than 0.05 Bitcoin. We can see how much was taken out in fees, and so what the total remaining transfer was. And it is this anonymity that makes this information safe to consume publicly. In other words, it is the fact that we don't know who these participants are. They're very highly anonymous. It is not very easy to look at this information and figure out which human beings or organizations these identities or these accounts link back to. That's why you can go out on the web. Anybody can pull up their laptop or their phone and view this exact same information, but try calling up your bank and asking them if you could view the same information about their customers. They likely would not be very happy to share it with you. The other thing I'll call out about this transaction, and you'll see the difference when we look at Hyperledger in a minute, but look how structured this data set is. This is a very, very structured data set that captures these transactions. If we wanted to add some custom data in here as part of this transaction, there aren't really many good places to do it. All right, so that's Bitcoin and blockchain 1.0. About 6 years later, in July 2015, another very big project in the blockchain space goes live, and that's a project called Ethereum. And Ethereum kind of picked up where Bitcoin left off. It gives us many of the same features. So just like Bitcoin has its own built-in currency, also called Bitcoin, Ethereum has its own built-in currency called Ether. So just like people can trade Bitcoin back and forth and use it to make payments to one another, we can do the same thing with Ether on the Ethereum blockchain. What Ethereum added was support to track any kind of asset on the Ethereum blockchain, not just Ether. So we can track things that have nothing to do with any sort of financial transaction. And I'll show you an example of that in just a couple slides. Just like Bitcoin, we have a single shared ledger. So if you go out and you use the Ethereum mainnet, you're using the ledger that is shared with everybody else on planet Earth. If you stand up your own private instance of Ethereum, perhaps behind your firewall, well, then there's just one single shared ledger that everyone who's behind that firewall shares together. So every instance or deployment of Ethereum, it's just going to give you one ledger. Far and away, Ethereum's biggest contribution to the blockchain space was this introduction to the idea of smart contracts in the Ethereum virtual machine. And if you're just new to blockchain and you're hearing this word smart contract, I know for me personally, contract, when I first got into blockchain, had a very strong mental association in my mind. Whenever I hear contract, I tend to think of a legally binding agreement between two or more parties. When you hear about a smart contract on the blockchain, that's just computer code. It doesn't imply any sort of agreement. There's nothing legally binding about it. So don't read too much into that word contract, but just know that what Ethereum gave us and what defined these blockchain 2.0 platforms is that now we can add our own logic. So we have a ledger we can use to track data, to track our transactions, and we can write code to define how those transactions should be handled and processed. So one of the examples we talk about in class is, imagine going to the store and using your phone to scan some produce there in the produce aisle and seeing right there on your screen the provenance of that item. What orchard did those organic apples come from? When were those trees planted? When were the apples harvested? What sorts of pesticides were used to treat them along the way? I could see all this information on my phone, and perhaps in this hypothetical application we're talking about, I can sign up for alerts, because when those organic apples reach my local market, they sell out very quickly. Well, if we were going to build a blockchain application like this, that logic, that computer code that sends me an alert, sends me a text, sends me an email, that's going to live in a smart contract. That's where I'm going to put that logic to deal with that type of event occurring. And as I mentioned, this is really what ushered us into the second generation of blockchain platforms, the generation that we're in today and that Hyperledger also fits into. Ethereum also gave us a token standard known as the ERC20. So if you wanted to create your own coin or token, for several years now, Ethereum has been the platform of choice. Up until this point, Hyperledger has not offered a native coin or token model. There's one coming, and that's pretty exciting. We'll talk a little bit about that later when we look at some of the features being alpha'd right now as part of the version 2.0 release. Ethereum, just like Hyperledger, has no native sense of identity. All of our users are anonymous. And just like in the Bitcoin world, that means that all of our data is fully transparent. And the primary focus of Ethereum is a little bit expanded from what we had with Bitcoin. With Bitcoin, we were really just focused on a platform to help facilitate digital payments. Ethereum really aims to be a platform to build applications on top of. And typically these are consumer-facing applications rather than enterprise or B2B applications. We can look here at an Ethereum transaction, and you can see this looks very, very similar to a Bitcoin transaction. We're still capturing our sender and our recipient in a highly anonymous form, and that makes it safe to share a lot of this, what would otherwise be very sensitive data. So I can see that someone made a payment to someone else and how much that payment was made for. We have a financial transaction, just like we had on Bitcoin. We can also use Ethereum for non-financial transactions. And this is an example of an Ethereum smart contract that we use in our developer and admin classes that we use to manage sample elections on the Ethereum blockchain. And I'll zoom in a little bit here. And you can see that down here, amongst other things, we have this input data field, and I can capture some information. In this case, I'm capturing a vote for Oksana Davis in this election for the coolest person in the class. You can also see that the value of this particular transaction is 0. This is a non-financial transaction. In other words, we're using the blockchain to record the fact that this account cast a vote in our sample election for this particular candidate. So we're able to deal with financial data, financial transactions, and non-financial transactions as well. So things get a little bit more expanded in Ethereum. And then finally, we get to Hyperledger. Hyperledger came out right on the heels of Ethereum. So Ethereum was July 2015. Hyperledger comes out December 2015. Many people associate Hyperledger to IBM. IBM is a very big, very vocal backer of Hyperledger right now. In fact, if you've seen some of the blockchain commercials running on primetime network TV, those have been brought to you by IBM, and those are all about Hyperledger. What surprises a lot of people to learn is that Hyperledger is not a proprietary IBM offering. It is an open source project. Many parts of Hyperledger started life at IBM, but IBM has decided to turn that project over to the community. And Hyperledger actually has over 220 different corporate backers and sponsors. You can go to their project site and view who they are, but some very, very big names if you go and you browse who's involved with this project. But being open source, that means if you want to stand up Hyperledger, if you want to start building solutions on it, you don't owe anybody any licensing fees. You don't have to sign any maintenance agreement. You don't have to sign any kind of upkeep agreement. Now, those agreements may be part of a cloud hosting option if you decide to go that way, but for the platform itself, it is fully open source and non-proprietary. So some differences between Hyperledger and Ethereum. First and foremost, Hyperledger doesn't offer its own native token or coin model. I hinted a little bit that maybe that's coming. We'll talk about that a little later. But for right now, for History up until this point, Hyperledger has not had its own native token. That doesn't mean that you cannot go build your own token architecture. You absolutely can, and many people have, and you can leverage some of the work they've done. It's just to say that this feature is not native in the platform right now. Just like Ethereum, we have a ledger that can be used to track any kind of asset. So we looked at Bitcoin, and Bitcoin was only focused on one type of asset, and that was Bitcoin itself. We looked at Ethereum and we said, hey, Ethereum's focused on a very specific type of asset called Ether, and we can design it to manage, track, and manage any other kind of asset we want as well, perhaps a vote in an election. And then we get to Hyperledger, and we again have this same freedom to track and model any kind of asset or object we want. Hyperledger is a little unique in that it introduces us to this idea of channels and multiple ledgers. So on the Bitcoin and Ethereum platforms, remember we just had one single shared ledger. And as long as you could get onto the network, you could see everything there was to see on that ledger. Hyperledger breaks that out a little and says, no, it's not enough just to have one that everybody shares. We're going to have multiple ledgers, and you can use as many or as few as you want. We'll talk about this a little bit later in a concept called channels. Just like Ethereum, Hyperledger is a second generation platform, a 2.0 platform. So you can write smart contracts in Hyperledger as well. In the Hyperledger world, smart contracts are often referred to as chain code, but you'll hear both terms used interchangeably. What really starts to make Hyperledger different, in addition to this concept of having multiple ledgers, is that it is not an anonymous platform. We give up anonymity for identity, and we give up full transparency and open access for a permissioned solution. And so whereas Ethereum was a platform generally focused on creating consumer-facing applications and solutions, Hyperledger is a platform generally focused on building enterprise applications, B2B solutions. And not just any type of enterprise solutions, it is particularly targeted towards building cross-organizational solutions. So if you need a solution that's going to be used at more than just your organization, a solution that's going to be used across your business network by all the other participants in that network, well, then that's really what Hyperledger was designed to provide. And if we look at a Hyperledger transaction, you can see compared to something like Bitcoin or Ethereum, this is very, very free form. You can see in this particular example, we've said, hey, for a member of our site, we want to track a balance, an account balance. We want to capture their email. We also want to capture their first and last name. However, for a different business scenario, different context, different use case, we may choose to capture completely different pieces of information. So a lot of the rigidity that we saw in a Bitcoin or an Ethereum transaction is gone, and it's replaced by something very, very free form. So based on what we've learned so far, what you know about blockchain so far, if we were to describe a blockchain, if we were to list out the properties or attributes of a blockchain, of something public, open, and permissionless, something like a Bitcoin or an Ethereum that we hear about most of the time, well, we would likely describe it using these properties or attributes. We would say that a platform like Ethereum or like Bitcoin, it gives us a decentralized ledger, meaning we have a ledger with multiple copies stored across the network, multiple redundant copies. And this decentralized ledger has the capacity to store any type of data. On a platform like Ethereum, this ledger is shared, meaning every node has a full copy of that ledger. There's only one version. And everybody who can get onto the network can see and access and work with that one version. So that one version is shared in its entirety with everyone on the network. This ledger is immutable, it's permanent, it can't be edited, it can't be changed, it can't be altered. Any data we commit to it is permanent. As we've talked about, these platforms like Bitcoin or Ethereum, they don't have any native sense of identity. If you want to de-anonymize your users on a platform like that, you have to figure out a way to track and manage identity. By default, they're anonymous. And by proxy, they're fully transparent. Because I can't have any kind of permissioning until I have identity. Identity is a prerequisite for permissioning. On networks like Bitcoin or Ethereum, we have group consensus, meaning the entire network will periodically stop. So every node or server or computer on that network can compare their data with every other node and make sure that at least a simple majority of them have the same data in common. And then finally, on a platform like Ethereum, on a second generation platform, we have this idea of smart contracts. So now I use blockchain not just as a way to store transactional data, but I can also take action on that data by programming my own logic into a smart contract. And this is really the attribute that transforms blockchain from just being a simple record keeping or data storage solution into a workflow or process automation or BPM solution. So if we look at these properties, these attributes of a blockchain, and we ask ourselves, are these good or bad? Are these desirable or not? From an enterprise context, from a business context, well, we can see that some of these attributes, the ones in green, are desirable and we would want to keep if we're going to use blockchain to build business or enterprise-focused solutions. Other attributes, the ones in red, are most likely undesirable. And there are things we would want to address, remove, or replace in a platform before we started using it in the enterprise. So if we review these quickly, looking through the lens of an enterprise solution, we can say, hey, we have a decentralized ledger. Is that a good or bad thing for a business solution? Well, it's probably a good thing. This ledger can store any type of data. All right, well, that sounds pretty good too. This one ledger is shared in its entirety with every participant on the network. Well, in a business context, from an enterprise point of view, that's generally undesirable. I don't want to share all my information with everybody in the world. I want to control who can see what parts of my data and under what circumstances. I have anonymity, and by proxy, full transparency. Anonymity and full transparency, well, these are the two properties that make a public permissionless platform work. Anonymity and full transparency are really the only reasons that two complete strangers on opposite ends of the earth can trade Bitcoin with one another and have a very, very high degree of trust that they're both being honest and that neither one is going to get ripped off or cheated. However, when we talk about a business solution, an enterprise solution, very often anonymity and full transparency are the two least desirable qualities there are. Generally in the business world, I don't want anonymous users. I want to know who my users are. And I want to know who they are because I don't want everything to be fully transparent. I want to be able to control who can see what parts of my data and under what circumstances. Group consensus is another area that subtly changes on a platform where we do away with anonymity. Think about it this way. If I have identity, if I know who all my participants are, well, then I know who the participants in any particular business transaction are. And that means if I know who the participants are, we can move from group consensus to participant consensus. In other words, if you and I do business back and forth, and you and I have a transaction, and for that one transaction, you and I completely agree on the outcome, there is no disagreement between us, well, then the rest of the world should just take our word for it. That outcome we both agree on represents the truth of that transaction. Unless we specifically ask for help, we don't need anybody else to get involved to help validate that transaction. So it's a very subtle but very powerful shift. When you get into the Hyperledger world, we move away from group consensus and we move towards participant consensus, simply gaining consensus from the participants in a transaction and no one else. And then finally, smart contracts, this ability to add my own logic into a solution, to use blockchain as a workflow or BPM platform. Well, obviously, that's a very desirable thing from a business standpoint. So the story of Hyperledger specifically, and of enterprise blockchain platforms generally, is how do we keep all of these properties in green that we know and love about blockchain while addressing some of these items in red? And if you look at what we have to address, there are 4 real big issues here. The ledger is shared with everybody on the network. All my users are anonymous. All my data is fully transparent. And I'm using group consensus, not participant consensus. So we're going to talk about how Hyperledger addresses each of these 4 issues. Let's start off with the very first one. The ledger should not be shared with everyone on the network. Right? I don't want to share all of my data with everyone. I want to control who can see what. I want to create permissions around my data. Well, the solution to that in the Hyperledger Fabric world is a feature called channels. Channels offer you a way to create multiple different ledgers, and each one can have a very unique set of permissions. Let's explore this a little bit deeper with a hypothetical example. So, of course, as you guys probably know, anytime we have any kind of hypothetical example in sociology, economics, physics, etc., we have to use our best friends, Alice and Bob. And so we've brought Alice and Bob in today to help out with this little example. So Alice manufactures electronic devices. She's the CEO of a very Apple-like company, and they make all of these very, very popular consumer electronic devices. Bob owns a chain of retail electronic stores scattered throughout North America and Europe. And Bob happens to be a major retailer of Alice's electronic devices. Now, Alice does business with many different retailers. Bob is just one. Bob does business with many different manufacturers. Alice is just one. But Alice and Bob together have negotiated a very special low price. Bob is a very good negotiator. And so he's negotiated a much lower price from Alice than most other retailers get. Now, in this kind of scenario, think about what would happen if we were capturing this data and we only had one single ledger available. There was only one place we could put it. That means that the price that Alice and Bob have negotiated between the two of them would be public knowledge. And that means that every other retail store that Alice does business with would see the special low price that Bob is getting. Chances are Alice could not afford to give that special price to everyone. And so that's really not data Alice wants to share. Similarly, if we only had one ledger and it was shared with everybody, well, then every other manufacturer would see the price that Bob was paying to Alice. And that might be information that Bob doesn't want to share. So rather than keeping all this information on one ledger where everyone can see it, in the Hyperledger Fabric world, we can create a channel. And one of the things that a channel comes with is its own ledger. That means that Bob and Alice can set up a channel between themselves. And all that lives on that channel is information about their transactions back and forth. And they can secure that channel however they want. If Alice is doing business with another retailer, she can conduct that business on a separate channel, a channel that Bob has no insight, visibility into, or even awareness of. And similarly, as Bob is transacting with other manufacturers, he can do that on channels they share together, keeping all of that business data confidential from Alice. All right, well, let's make it a little bit more complex than that. Let's add in some different components, right? Just keep in mind, hey, every time we talk about a channel in Fabric, well, we're talking about a grouping of things. A channel comes with a ledger, so we have our own unique ledger to keep data on. It comes with an area to deploy our smart contracts or our chain codes. And it comes with a set of permissions. And again, check the notes on these slides if you're interested in learning more about channels or getting a more technical overview. There's some really good links I put down in the notes. All right, so let's add some more folks into this. And now we can see where channels really become powerful. So Alice and Bob do not work in a vacuum. In order to get those products from Alice's factory to Bob's retail locations, to Bob's retail stores, they need some help. They need some other participants in this business network. So we have Charlie. Charlie runs the shipping and logistics company. Charlie's the one who's going to ship these these electronic devices that Alice produces all around the world. Charlie does not need to know all of the information about the transactions between Alice and Bob. The only thing Charlie cares about is what's being shipped and where is it going. What do I need to pick up from Alice's factory and where do I need to send it? Anything else Charlie doesn't need to worry about. So that special price that Bob negotiated with Alice, Charlie doesn't need to know anything about that. The payment terms that they worked out, Charlie doesn't need to know anything about that. All right, well, now let's enter Diane. Diane is another participant in this business network, and Diane is the banker that financed Bob's purchase of these electronic devices. So Diane needs to know some information. But she needs to know very, very different information from Charlie. Just like Charlie, Diane doesn't need to see the full picture. She just needs to see a subset of the data. So Diane doesn't care what's being shipped or where it's going. Diane wants to know, what is that price that Bob and Alice negotiated? And Diane probably also wants to see Bob's sales figures. How well are these items selling? What kind of risk am I assuming on this loan or this financing? And by the way, Bob's sales figures, how these items are selling in his store, is most likely not going to be information that Bob is going to share with Alice unless they've worked out some kind of just-in-time inventory solution. Most likely that's information Bob is not sharing with Alice. So the fact that Bob and Diane can share a channel allows Bob to share those store sales figures with Diane without sharing them with Alice. All right, let's add in a couple more participants and then we'll see how this all fits together. Our next participant is Evelyn. And Evelyn works with the Port Authority. She works with the Customs Agency here in the receiving market in the US. And just like Charlie and Diane, Evelyn also only needs to see a subset of information. She doesn't need to see the whole whole set of information. Evelyn just needs to know what's in those shipping containers. So she just needs to see bills of lading. She needs to see shipping manifests. She just needs to make sure that no dangerous or prohibited goods are coming into the local market, that all appropriate taxes have been paid, et cetera, et cetera. Evelyn does not need to know what price Alice and Bob negotiated with each other. She does not need to know what Bob's sales figures look like. And then last but not least, we have Frank. And Frank runs an advertising agency. And Frank has got a brilliant new marketing campaign all queued up and ready to go to get consumers excited about purchasing Alice's new electronic device in Bob's stores. And the only thing that Frank needs to know is, when is that shipment arriving in country? When are we unloading those containers from the dock? Because it's going to take about a week from the time that shipment arrives here in the US to when those items actually appear on the store shelves. And we want to start that big marketing campaign with that 1 week head start. If we start it before, well, we're just going to get everyone excited about a product they can't buy. And if we start that campaign too late, well, then we have these products sitting on the shelf costing us money, not being sold before we start to generate interest. So the only thing Frank needs to know about is, when is that first shipment arrive, so he can go ahead and kick off the advertising campaign. So think about doing all of this in something like Ethereum, where we only have one ledger. This would be very, very difficult. We would have to write our own permissions model. Think about facilitating something like this in a conventional relational database. This would also be very, very difficult. This would most likely involve, in a conventional database, not just securing things at the table level, but securing things at the column or field level. And if you spend any time in relational database administration, or you know anyone who does that for a living, ask them about how easy that is to set up and maintain and configure. It can be a very, very cumbersome proposition. Well, luckily, we can use this concept of channels in Hyperledger Fabric to help address this. We can say, hey, let's have one channel that Alice and Bob share. Excuse me. And this channel contains all of the information that Alice and Bob share together. Now, Alice is a member of many different channels with many different retailers. One of them happens to be the one she shares with Bob. Bob is the other side of this many-to-many relationship. Bob is a member of many different channels. One of them happens to be shared with Alice, but on this channel between Alice and Bob, they see all of the details of their transactions with each other. And we use data here from channel 1 to feed the rest of these channels, channels 2 through 5. So we set up a second channel for Charlie, for the shipping company. And on this channel, we copy the relevant information from channel 1 over to this channel. We copy the information about what it is that's being shipped and where it's going. The rest of the information from channel 1 that Charlie doesn't need to know about, we don't copy over into his channel. This means that Charlie has his very own channel that's full of just shipping information. And this channel can have its own unique permission set, because you see, Charlie isn't just an individual user. Charlie is the CEO of Charlie Shipping, and Charlie Shipping has hundreds, maybe even thousands of employees. And so Charlie wants each of those employees to have different access rights on his channel. Maybe only senior managers and above get to see this shipping information. Well, Charlie can manage permissions for his own associates and employees however he wants on his channel. We do the same thing with Diane. We create a channel exclusively for Diane. And on this channel, the only information we put is information about Bob's order or purchase from Alice, as well as some of Bob's sales records from his various stores. This means that when Charlie goes onto his channel, he doesn't see any of the information that Diane sees and vice versa. They don't even know that this information exists. Right? We can similarly create channels for Evelyn and channels for Frank. And you can think of these very much as being like television channels. We only put the content on each channel that relates or is relevant to the audience for that channel. So the only thing that goes on channel 2 is the content that's relevant for Charlie. Just like if you sit down to watch PBS, you could expect to see very, very different programming than if you sit down to watch Fox or you sit down to watch Univision. Each of these different channels caters to a different audience with a different type of content. That's exactly what we're doing here in Hyperledger Fabric. All right, problem number 2, we said we had to address. I don't want my users to be anonymous. I want to know who they are. Very often, anonymity is not a benefit in an enterprise solution. How do we address that in Fabric? Well, we do that with a component called the membership service provider. It's a very antiquated analogy, but you can think of the membership service provider as being exactly like the phone book, as being like the white pages or the yellow pages. It's simply a listing of all of the valid identities on a network. So a phone book tells you all of the valid phone numbers on the network and to whom they belong. Well, the membership service provider is going to tell us who are all the valid members at your organization, who are all your employees. This is a pluggable component, and it contains a list of all the known identities at your organization, both human beings and other line of business systems, because Fabric will happily interact with both. Very typically, this is some kind of LDAP, like Active Directory. OAuth is also fairly common. Forms-based authentication is used from time to time. But essentially, this answers the question, anytime a user is submitting a transaction to the network, this attempts to answer the question, are you using a valid identity? Are you claiming to be someone we know about? This removes anonymity. This now means that every single user on our network has an identity. All right, problem number 3 we talked about. We don't want to share all of our data with all of our users all of the time. We want to control which of our users can see which parts of our data under which circumstances. And to do that, we use channel permissions and ACLs, or access control lists. This lets us set up permissioning within a channel. So remember the channels we just looked at? We had a channel for Charlie, channel number 2 here, that only contains shipping information. Well, Charlie can now come and define permissions on his channel, because maybe he doesn't want to share all the information on that channel with everyone in his organization. If you work for Charlie's shipping company and you work in the HR department, you probably don't need to know or care about what's being shipped and where it's going. So you might not have access to any of that information on the channel. So within the context of a channel, we can set up permissions, and we do this using a technology or an approach called ACLs, or access control lists. Of course, all of this is only made possible by that membership services provider, which gives us identity in the first place. This, oftentimes compared to a database solution, is much cleaner and easier to administrate from a permissions management standpoint, because I'm only managing permissions on a channel, and only a subset of my data lives on that channel, versus a database where all my data lives in one single repository, and I have to manage all of my permissions against that entire data set in a complicated web that sits on top. We'll talk a little bit more in a minute about that concept. And then finally, We said, hey, we don't need group consensus on a platform where we have identity. We can use participant consensus. I don't need the entire network to stop and validate each transaction. I can have the participants validate their own transactions according to their own rules. And in Fabric, this is accomplished by something called an endorsement policy. This allows me to define what does consensus look like for a certain piece of functionality on my channel. Again, check the notes in the slides if you want to go deeper on all of this. There's some really good links in there that will explain a lot of these high-level concepts in much, much greater detail or more technical detail. But essentially what endorsement policies allow us to do is define what does endorsement or agreement or consensus look like for this particular business process on this particular business channel. And this opens up some very, very interesting possibilities. Because I can define endorsement differently on different channels, this means I can stamp out the same smart contract or the same business process, and in each instance, I can manage it different ways. Let me give you an example. We talked a little bit about Alice and Bob. Right? Alice manufactures electronic devices. Bob is a retailer. So presumably Alice does business with many retailers. And each retailer can order merchandise from her. They can place an order with Alice. That business process, the steps that Alice follows when that happens, is likely the same or very, very similar regardless of who the customer is. So if Bob's line of retail stores is purchasing from Alice, her business process is likely identical or very, very similar than if Tony's electronic stores is purchasing from Alice. However, let's just assume that Alice and Bob are family friends, that Alice's electronic manufacturing device company was started by her great-great-grandfather, and Bob's retail stores were started by Bob's great-great-grandfather. And Alice and Bob, their families have been doing business together for 4 generations. Alice and Bob went to school together. They grew up. They played on the playground together. So they know each other very, very well. Alice may be doing business with a different retailer, let's say Tony, that she just met last week. So Alice has a great deal of trust in Bob. She has not had enough time to build up a lot of trust in her relationship with Tony. Hyperledger Fabric allows Alice to write one smart contract that manages the place order process. Alice can then take this smart contract and deploy it to 2 different channels, one shared with Bob, one shared with Tony. On the channel she shares with Bob, endorsement or consensus is defined very, very loosely. On the channel she shares with Tony, consensus or agreement is defined very, very strictly. In other words, Alice can take the exact same business process and manage it to completely different standards based on her personal relationship with that other organization or entity. This can be very, very powerful. And this is something that is next to impossible to achieve using any kind of conventional technology. This channel architecture also allows us to use one infrastructure to accommodate 3 different types of voting or consensus scenarios. So a little bit later when we get to use cases, we'll look at Walmart. Walmart is deeply invested into blockchain, into Hyperledger Fabric, so much so that they have made it a requirement that all of their leafy green produce suppliers make the move onto blockchain by September of this year. So if we think about Walmart and these suppliers that Walmart works with, we can assume that in many cases, Walmart is much larger and more powerful than any of the suppliers that it works with. Well, if Walmart is using Hyperledger Fabric with their suppliers, that means that we can set up 3 different types of scenarios when Walmart and their supplier are trying to reach consensus or agreement on a particular transaction. We can say for some types of transactions, we want Walmart to have a very large, heavy, disproportionate vote. We want Walmart's vote to be equal to its disproportionate size and power in the marketplace. So when Walmart and that supplier have a vote and try and reach consensus, Walmart may have 80, 90, 95% of the voting power. On that exact same infrastructure, potentially even with that same supplier, but in a different context, different type of transaction, we can say, all right, Walmart and the supplier for this particular type of transaction have an equal vote. They have a democratic vote. It does not matter that Walmart is a giant multinational, multi-billion-dollar corporation, and this supplier is half a dozen employees on a family farm in Arkansas. In this scenario, Walmart and that supplier have an equal vote. Then we can go the other way. And again, this is all on the same infrastructure. These scenarios can all live side by side. This is simply managed through configuration. We can say, hey, for some type of transactions, we want that very small supplier to have a disproportionately large and powerful vote. So an incredible amount of flexibility on this platform to allow for very, very different types of consensus scenarios. Again, if you picture what would be involved doing something like this on conventional technology, you can start to appreciate how difficult, if not impossible, it would be to do this given the tool sets we currently have. And then if you come from a security background or you're interested in the security angle behind blockchain, well, there's a very, very interesting thing to consider when we're talking about a channeled platform like Hyperledger. And that is, there is no one single place where all of the data lives. Let me go back a few slides. Let's look at our channels again. We created channels 2 through 5 for Charlie, Diane, Evelyn, and Frank. And the only thing we put on those channels is what each of those participants needs to see. So if I look at channel number 2, all I'm seeing on channel number 2 is information about what is being shipped and where it's going. That is it. That means if I'm an attacker and I successfully breach channel number 2, I'm going to see all the information there is to see about what's being shipped and where it's going. I'm not going to see any other information. I'm not going to see any of the information from channels 1, 3, 4, 5, or any other channels that any other participants in this network may be involved in or may be a member on. Compare that to the database world. If we were going to keep all of this same information in a database, well, we would put it all into one single repository. And then we would control access by managing permissions on top of that repository. In other words, we very often would not create a separate database instance for Charlie. We would keep all of this information in one database, and we would only show Charlie the relevant information using permissioning that sits on top of that database. That means that if any attacker ever got access to that database, they could see the full picture. They could see every data point there was to see. This is something we call the God mode view. And you may have seen something like a screenshot from this video game, where you are literally looking down on the world and you can see the full point of view of every one of these actors or participants. Very often, this can be a much bigger risk from a cybersecurity point of view. This idea that, hey, if an attacker breaches the database, they see everything. If an attacker breaches one of our channels, they only see everything on that channel. And very often that creates a much, much lower risk exposure for sensitive data. All right, so we'll shift gears a little bit. We're going to talk about some core concepts and components behind Hyperledger. We're going to start off talking about the network architecture of Hyperledger. What are some of the actual components that make up a Fabric network? If you want to start planning a Fabric deployment at your company, what are some of the things you need to be aware of? So again, we'll start by talking about some of the differences between classical solutions, other blockchain solutions, and then Hyperledger. So when we talk about a classical network solution, we're generally talking about something that uses a client-server architecture. And that's kind of what you see called out on the left-hand side of this little graphic here. We have clients. Anytime a client wants something, they go request it from a server. The server gets that request. They send the data back. The client is happy until they go and they make their next request. And this is largely the model that we use on the internet today. This model has certainly served us well, but there are some potential shortcomings to this model. The first is, if you look at an architecture like this, it's pretty easy to see that there's a single point of failure. If I can attack that server, if I can remove that server, if I can take that server down, if I can compromise that server, well, then I've really compromised the rest of the network. Public blockchain platforms, things like Ethereum or Bitcoin, these generally run on what's known as a peer-to-peer architecture. And a peer-to-peer architecture is a very different kind of architecture from client-server. In peer-to-peer, we say that there are no clients and there are no servers. Every node or computer or server or user on the network, they are both a client and a server simultaneously. So on a client-server network, if I'm a client and I want something, I go ask the server and the server gives it back to me. On a peer-to-peer network, if I'm one of these nodes and I want something, I broadcast that request out to every other node on the network. And any node on the network that has all or some of that data that I'm looking for is going to send it back to me. If another node on the network makes a request and I have some or all of that data, I'm going to send it out. So I can be a client and I can be a server. Some of the advantages of this peer-to-peer architecture is you can see there is no single point of failure here. If I take out one of these nodes, I still have a fully functional network. So compared to client-server, peer-to-peer scales very, very easily and very well. It is extremely resistant to any kind of attack, especially any kind of denial of service attack. But right now, public blockchains that use this architecture are facing a pretty big bottleneck. And that bottleneck is, on average, a platform like Bitcoin or Ethereum will support somewhere in the neighborhood of 10 transactions per second worldwide. And this can vary a little bit depending on the day and the network conditions. Sometimes this goes as low as 5 or 6. Sometimes you can see it jump up to 12, 15, 16 sometimes. But usually we average about 10 transactions per second. And that may seem like a respectable number until we compare it to conventional technology. So if you look at Visa and their payment processing network, well, they can scale that up to over 70,000 transactions per second. And that's a few orders of magnitude greater. And then you look at Facebook and they take things even a step further. Facebook likes to brag that they can handle over 175,000 transactions per second worldwide. So when you start to compare these public blockchain platforms, something like the Ethereum mainnet or Bitcoin, to some of these conventional plays, you see that there's quite a bit of catching up to do. And so this left the designers and the architects of Hyperledger Fabric with a unique problem, which is, how do we have something which is blockchain, but can move past this bottleneck and scale up to a throughput that's going to be workable for business, something into the thousands to perhaps low tens of thousands of transactions per second. And the way that Hyperledger did that is they sat back and they realized that every node or server or miner on a network like Ethereum was performing 3 different operations. Every node on a network like that was first keeping a copy of that ledger. They were keeping a redundant copy. The second thing they were doing is they were executing any smart contract code. So if a user called a function out of a smart contract, every node's going to go off and execute that function. And then finally, all of these nodes or miners or servers or computers on a network like Ethereum, they're all working with each other to keep this ledger in sync, which means not only are they attempting to record the same data, perhaps more importantly, they're also attempting to record that data in the same order, because having the order right is critical as well. So the architects of Fabric looked at this and they said, if every node on this peer-to-peer network is doing 3 unique functions, what would happen if we created 3 unique node types? And then each node only focuses on one of those functions, not all 3. And so what we get in Hyperledger Fabric is a bit of a hybrid approach. Notice in this organization, this isn't nearly as centralized as client server, but there's still some servers in here. So it's not quite as decentralized as peer-to-peer. It's a hybrid, it's a mix. It's the best, or depending on your point of view, the worst of both worlds. So we do have some redundancy, we do have some failover, we do have some fault tolerance, but we're not running in a completely peer-to-peer fashion. However, by taking this approach, we're able to scale up several orders of magnitude beyond what something like the Ethereum mainnet can provide. And so what we see in Hyperledger Fabric are 3 different types of nodes or servers. And as you're planning out either a development deployment or a production deployment of Fabric, what you're really going to be planning is, how many of these nodes do I want to set up? How do I want to configure them and use them, and where? So we said the first thing that every node on a blockchain network does is it keeps a redundant copy of the ledger. And in the Hyperledger world, the nodes that do this for us are called our committing nodes. The only thing a committing node does is it keeps a redundant copy of the ledger. It's just there for redundancy. We said the second thing that a node does on a blockchain network is it executes any smart contract code. Well, that's what the endorsing nodes on a Hyperledger Fabric network are going to do. The only thing they exist to do, or their primary function, is to execute smart contract code. Now, they will also, just like the committing nodes, keep a redundant copy of the ledger. That way we have even more redundancy, and the endorsing nodes can do this because it doesn't really add any overhead. And then finally, We have our third type of node. Remember, we said our third responsibility for a node on a blockchain network is to make sure that all the ledgers have the same data in the same order. And the third type of node we have on a Fabric network are called our ordering nodes. And collectively, they form something called the ordering service. The ordering service is the piece in Hyperledger that works to keep all of the same information on all of the same ledgers in all of the same order. In fact, if you come from more of a traditional blockchain background, check the notes on this slide. There's a really good technical deep dive that explains some of the benefit of this ordering service. And it explains, interestingly enough, why you will never see a hard fork based on a data disagreement in Hyperledger. So little teaser there, if you're coming from more of a traditional blockchain background, there's no such thing as a hard fork in Hyperledger. You can dive into some of the detailed links and find out why that is. It's a pretty interesting read. All right, so how does all this come together? What does a transaction look like in something like Hyperledger Fabric? And if you're familiar with the transaction model in Bitcoin or in Ethereum, you'll see this looks quite a bit different. There's some very, very different steps here. Well, all of this starts when an end user is going to initiate or submit a transaction. And when we say end user, we could be referring to a human being. We could also be referring to another line of business system. So this could be someone in your office pulling up a web interface and submitting a transaction. This could be your ERP system doing this behind the scenes in an automated fashion based on some internal conditions. Anyway, however this transaction is initiated, the network, the Hyperledger Fabric network, is going to receive it. And the very first thing that the Fabric network is going to do is it's going to reach out to the membership service provider for your organization, and it's going to attempt to see if the identity you're claiming is a valid one. So you may say, hey, Bob, or hey, Alice, this is Bob. I want to order some new electronic devices. And that's Bob initiating this order transaction. Well, then the Fabric network is going to go out to Bob's membership service provider. So this might be Bob's instance of Active Directory, and it's going to ask Bob's Active Directory, it's going to ask Bob's membership service provider, hey, do you have a record for someone named Bob? Is Bob actually a valid user on your network? And we're going to get a yes/no answer to that. If we get a no answer, well, then we just ignore the transaction. We don't take it any further. This transaction is coming from a user that our membership service provider doesn't even know about. However, if our membership service provider comes back and says, yes, Bob is a valid user, all right, well, then the next thing we need to do is we need to validate whoever is submitting that transaction is actually who they claim to be. So Bob is a valid user. Are you actually Bob? The way we do that is with a component we haven't explicitly talked about in Fabric. That is a component called the certificate authority. And essentially at this step, we're just using public-private key cryptography to validate the identity of the user. In other words, this transaction proposal is being submitted to the network, and it's been signed with a private key. If I take Bob's public key and I can decrypt that transaction request, well, then I know that that transaction request was signed or encrypted with Bob's private key. And that this user who is claiming to be Bob must actually be Bob because they have access to Bob's private key. So now we validated that our user is actually valid, and we validated they're actually who they claim to be. We have one more check to do before we can go ahead and process that transaction. And that is, we need to make sure that this user, in this case Bob, actually has permissions to do that on this channel. So we know that Bob's a valid user. We know that you're Bob. Are you trying to do something Bob actually has permissions to do? And this is going to be verified using our channel permissioning and our ACLs, our access control lists. Assuming that Bob is doing something that Bob actually has permission to do, okay, well, now we have a valid transaction. Now our transaction is going to get broadcast to all of the endorsing nodes or all of the endorsing peers on the channel. Each of these endorsing nodes is going to independently execute that smart contract code and come up with a result that they're going to send back to the client. So that means none of these endorsing nodes has any idea what any other node is coming up with. And it's up to our client here in step 7 to look at the answers they get back and determine whether or not we've reached consensus, whether or not we've reached agreement. For example, maybe on our channel, we have 12 endorsing nodes. And we've created a rule which says as long as 8 out of 12, as long as 2/3 of them come up with the same answer, we're good. We'll consider it a valid transaction. We'll add it to the ledger. Maybe we have a different channel or different configuration and we have 12 endorsing nodes, but we've said in this example, 11 out of 12 have to agree or 12 out of 12 have to agree. Well, it's here in step 7 where we're looking at a piece called the Endorsement Policy. That's where those rules are defined that tell us what is endorsement, what does an agreement look like for this smart contract on this channel. If we've reached agreement, if we've reached consensus, well, then our client application is going to tell the ordering nodes that there's a new transaction to be added to the ledger. And at that point, our committing and endorsing nodes are going to go ahead and add that transaction to the ledger. That transaction becomes an official part of the permanent record. So if we look at what one of these channels looks like in Fabric, we would say that, hey, we have some number of committing nodes, some number of endorsing nodes, some number of ordering nodes. The number you have of each one on each channel is completely dependent on what it is you're trying to achieve, who you're working with, and what that business process looks like. So in this simple example I've drawn up here of one single channel, I've got 8 endorsing nodes, 6 ordering nodes, and 3 committing nodes. Why 8 endorsing nodes and not 10 or 4 or 2? Well, just because. No particular reason. Just how I drew up this example. But this is one of the things you're going to want to work to understand if you're thinking about deploying Fabric at your own organization. What is the right architecture? How do we pick something that's not just an arbitrary example? How do we know what the right way to build this out is, how many we need? And what we're talking about here is simply a configuration play. These 8 endorsing nodes may get used across many different channels. This may only be one. These ordering nodes collectively form something called the ordering service. And very often, one ordering service is used across every single channel on a network. Very often, there isn't a reason to have a dedicated set of ordering nodes for a channel. You only do so in solutions where security is a very, very, very high concern. So these nodes are shared across channels. This is just one particular configuration. And what we're looking at is really just a configuration diagram. We're not looking at any kind of physical architecture. So if we look at who owns each of these nodes, When we might say that for channel 1 between Alice and Bob, some of these are owned by Alice, some of these are owned by Bob. We join them together through configuration so they know how to speak to each other. If we were going to draw out all the different channels that we listed back on that previous slide, all 5, we would see that we have nodes on each channel owned by Alice and Bob and Charlie and Diane and Evelyn and Frank. They all potentially could have some skin in this game. And this is something that makes Hyperledger very, very unique from other traditional solution platforms. Hyperledger really exists as truly shared infrastructure between organizations. Very often, as you're just getting up to speed on blockchain, especially something like Hyperledger, it can be difficult to understand what is the difference between blockchain, between something like Hyperledger and a traditional database. This is one of the biggest areas of difference between the two. If I set up a database, I am the owner of that database. I may build a distributed database. I may put it out on a network. I may give the rest of you access to it. But at the end of the day, a database still has an owner. It still has an administrator. So all I would be doing is setting up a resource I own, I manage, and I control, but I'm willing to share with the rest of you. Hyperledger Fabric is very different in that if we all decide to participate on a Fabric network, I own some of the infrastructure and you own some of the infrastructure. And everybody brings their piece and they connect their pieces together. So there is no one central owner. There is no one central administrator. And this can have some very, very interesting effects. We'll talk a little bit later when we review some use cases about how the National Association of Realtors used Hyperledger to solve an issue, pardon me, where a database might have been technically adequate, but this ownership issue created some friction. Similarly, we can look at how all of these are hosted and deployed. And in full disclosure, because I'm lazy, all I did was take this exact same diagram and change the legend down here. So conveniently, all of Alice's nodes are on-prem and all of Bob's are cloud hosted, but there could be a mix in there. All I'm really trying to communicate here is that these individual nodes can be hosted any way we want to host them. In the Fabric world, these are just Docker containers. So I can host them on-prem. I can host them out in the cloud. I can host them with Bluemix. I can host them with Azure. I can host them with AWS. I can host them with DigitalOcean. I could say, you know what? I've got 6 different nodes here in the ordering service. 2 of these are going to be on-prem. The 3rd one's going to be in AWS. The 4th one is going to be in Azure. The 5th one is going to be in DigitalOcean. And the 6th one is going to be in my backup data center on the other side of the country. I'm just joining these together through configuration. And you can look at this channel architecture and go back throughout these transaction flow steps, and you can kind of envision what's happening. Once we've validated that we have a valid transaction, you're a valid user, you are who you say you are, and you have permissions to do what you want to do, well, that transaction is going to get processed by all of these endorsing nodes. They're going to send their results back to the client. If the client says, hey, we have enough consensus, I want to include this on the ledger, they're going to tell the ordering service, these green nodes. Our ordering service is going to tell our committers and also our endorsers, go ahead and add this transaction to the ledger that you keep. And again, if you're interested in learning more about this, check out the links in the notes. You can get a lot deeper into this process and how it works. All right, so There are many, many new releases of Fabric coming out. It seems like constantly. And in fact, we just went from 1.4 to 1.4.1. So a lot changing right now in the Fabric world. If you're wondering what's new in the latest version of Fabric, again, some really, really good links down in the notes on these slides you can dive into and check out in a little bit more detail. But I'll kind of cover some of the big ones. Probably the biggest addition in 1.4.1 is the Raft ordering service. So if you've set up and managed an ordering service in Fabric, you know that you have or have had up till now 2 different choices. You could use the solo ordering service for dev environments where you just want a single node providing that ordering service functionality. And that's great for development purposes, but it's not recommended for production because it creates a single point of failure. So as you know, when you go over to production, we've been using Apache Kafka and Apache Zookeeper with Kafka to manage this ordering service, to provide this message queuing functionality. Well, now as of version 1.4, we can use Raft, the same Raft consensus protocol that you see used on a lot of other blockchain platforms as well. Compared to Kafka, it's faster, consumes less energy, and it offers greater performance. Kafka is still an option, so you do not have to move to Raft if you don't want to. Be sure to dig in and see some of the advantages and disadvantages of both. But just know that you have another additional option here with Raft that you didn't have before. There is the new operations service. So if you're an administrator of a Hyperledger Fabric network, definitely take some time and read up about some of the new functionality offered in the operations service. This gives you some new and interesting tools for managing and monitoring nodes and containers and their configuration on a Fabric network. So definitely designed to make the system administrator's life a little bit easier. In this latest release of Fabric, there's been enhanced support for Node.js and Java. Of course, if you've done anything in Fabric, you know that the de facto language for Fabric is Go or Golang. There's also support for Node.js, server-side JavaScript, as well as Java. And in 1.4.1, there's enhanced support. So now feature parity has largely been achieved between Golang and Node.js and Java. So really whatever language you're familiar with, whatever you're using internally at your organization, you can go ahead and leverage on Fabric. So no longer do you have to learn Go if you're not a Go developer, if you want to start writing some smart contracts directly on Fabric. And finally, private data was a big feature that was announced in version 1.2 of Fabric. This is simply a way that we can secure data on channel, so we don't necessarily have to create another channel for areas where we just want to share data for light access or auditing purposes. Well, 2 new features have been added under the private data feature, reconciliation and client access control. And again, on the notes in this slide, you can see more details, as well as links to learn more about some of those enhancements. All right, so that's our current production version, version 1.4.1. Version 2.0, the next major release, is out right now. There is an alpha release out. So this is kind of exciting. No longer do we have to talk about what we think might get included in 2.0. Now we can actually talk about what's in the alpha or beta release. So we're still at alpha release if you know anything about pre-production releases. The alpha release is the first one. It's going to be the one with the most rough edges. So a couple things to keep in mind. If you want to get hands-on with 2.0 alpha, you certainly can. But you are not working on a production platform. There is no production support. Anything you build on top of it may break once we get to a beta release or a production release. So this is just a testing release. Unless you really, really have a strong appetite for risk, Don't build anything production grade on top of it. And just know that as an alpha release, there's absolutely zero upgrade support. So if you install 2.0 alpha and a few months go by and the beta comes out or the production comes out and you want to upgrade, tough luck. You're going to have to wipe out your environment and start over with a fresh install. However, that being said, we're starting to see some very interesting features as part of version 2.0. 2.0 is going to be a very significant release. There is a big emphasis in version 2.0 on decentralized governance. There's a very, very common theme here. This idea that in Fabric up until now, there was usually one organization that managed things on a channel. So if we needed to change the parameters of one of our smart contracts, or we wanted to go and upgrade one of our smart contracts, on all the current versions of Fabric, that was just done by one single organization. So if my organization wrote the smart contract, I could go up there and I could upgrade it whenever I wanted. I could change the deployment parameters anytime I wanted. Fabric 2.0 makes those decentralized and gives us options to have voting and elections and buy-in for that. So if 5 of us share a channel together and I want to upgrade the smart contract, we can put a rule in place that 3 out of 5, 4 out of 5, 5 out of 5 of us have to agree on that upgrade before it can actually take place. No longer can just one member go off and make those sorts of changes on their own. So much more democratic and decentralized tool set for governance and management of Fabric networks and channels. Upgrades to endorsement policies, chain code packaging, some administrative tools for starting, managing, deploying, tearing down chain code packages have all been added. Again, plenty more information down in the notes with some links. Another big, probably I think the biggest piece of 2.0, or the piece that is at least going to get the most attention when it goes live, and that is Fab Token. You'll sometimes hear this called Fab Coin. And as I mentioned, up until now, Fabric has not had its own native coin or token model. And if you wanted to create your own coin or token in Fabric, you had to do that from scratch. Well, Hyperledger's gotten a lot of feedback about this, that this is really something a lot of people feel is missing from the platform. And so what we're going to see in 2.0 is the Fab Token architecture. This is a new architecture model and system for managing your own custom coins or tokens. So if you have a use case where you want to make digitized representations of some kind of physical or virtual asset, Fab Token is going to be a way to do that. You can, if you read between the lines, really see the direction that they're aiming the platform towards with Fab Token. In fact, just last week, there was another project that got announced as part of the Hyperledger project, and that was Hyperledger Aries. And you can go to hyperledger.org/projects if you want to learn more about all the different projects under the Hyperledger namespace. But Aries was a brand new offering that went live last week. And I've got a little quote here. This is actually from the Hyperledger press release on some of the things that Aries offers. And one of the features that comes with Aries is a cryptographic wallet for the secure storage and management of cryptographic secrets and other things used to build blockchain clients. So if you connect these two dots, you can see that Fabric 2.0 is going to give us a token model. Here's this new offering called Hyperledger Aries, and it gives us a wallet and way to securely store and manage cryptographic secrets and private keys. So now all of a sudden, Fabric 2.0 is going to have a token model and a native wallet system. So now it's really starting to compete with something like Ethereum or Bitcoin for doing any kind of asset digitization and possibly payment processing and reconciliation. And then the next real big major change coming in 2.0, as I mentioned, all of these node types that we looked at on a Fabric network. So all of our committers, all of our endorsers, all of our orderers. All of these different node types simply run in Docker containers. And up until now, the operating system inside each of those Docker containers has been Ubuntu Server. Starting in version 2.0, we're going to switch. And the operating system used for each of those containers is going to be Alpine Linux. Compared to Ubuntu Server, Alpine is much smaller, it's much lighter. It has a much, much smaller footprint, and it is an operating system that is designed with security in mind right from the beginning. So it is a very, very security-focused OS. It is not to say that Ubuntu Server is insecure, but Ubuntu Server is focused on being a very general offering, a Swiss Army knife. Alpine Linux is a little bit more focused on being a very, very secure container OS. So we should see the performance of our containers go up and the number of containers we can manage on our physical hosts go up as well. So some interesting things coming. All right, so you may be wondering if you've heard all this, well, how do I know if I've got a good Fabric use case? I maybe have some ideas in mind, or I've heard some stories about what other people are doing with blockchain or with Fabric. How do I know if Fabric is worth pursuing more in my organization? And so what we've got here is a series of 4 very simple yes/no questions. And if you're starting to think of maybe a use case or an idea that you might have, think in your head about how you would answer each one of these 4 questions. All we're looking for here is a very, very simple yes/no answer to each one of these questions. So let's review these questions and what they mean. And these can be used as a very high-level measure to see whether blockchain is worth further investigation or not. So the very first question we're going to ask ourselves, do I have one or more assets that I want to track? Do I have something that I care about? When we talk about assets, we're talking about something that can be physical and tangible, like a car, a cell phone, real estate. We can also talk about something that is virtual or intangible. A patent application, some intellectual property, a piece of digital content, ownership in an organization. All of these are examples of asset, but a blockchain solution is all about tracking the life cycle of some kind of asset. So things like Bitcoin, digital music, intellectual property, all could be assets. But if you don't have one or more assets you want to track, if you came to me and you said, Kris, I really need a way for employees at my organization to be able to message each other and communicate with each other better, well, this might not be a blockchain solution. We might be talking about an email enhancement or an instant messaging client. But if we have one or more assets we want to track, well, then there's a good chance we're potentially talking about something blockchain. All right, question 2. Do I care about the life cycle of an asset or how it evolves over time? In other words, do I just want to know the current state of things? Or is it not enough for me to know the current state? I need to know the history of something as well. Question number 3, how do my assets evolve over time? Do they do so randomly? Most assets in the business world don't just evolve randomly. They follow some type of well-defined process, some well-known rules. For example, we might have a business process that allows employees to submit expenses and then get reimbursed for those expenses. If an employee submits an expense report, we could probably safely assume that one rule of that business process is that an expense report can never have a status of paid before it has a status of received. So again, in most cases, our assets don't just evolve randomly. There's some kind of business process which drives that evolution. And then the last question, are you the single voice of truth for any questions about that asset? In most scenarios, you are just one custodian of an asset along part of a larger process. So let's think about Alice and Bob. Alice makes electronic devices. Bob sells them in his stores. The business process of getting those devices from Alice's factory to Bob's stores has many different custodians. Charlie, he ships all those goods from the factory to the stores. So Charlie is just a custodian in one part of that overall process. So if I had a question about those assets, if I had a question about any one of those electronic devices, who in that business network is the single voice of truth? Well, there really isn't one. If I have a question about those devices while they're being shipped, Charlie is that single voice of truth. But if I have a question about those devices while they're being manufactured, Charlie can't help me. I have to ask Alice. Very often the assets we're concerned about follow this model. We do not own them from the start to the finish of their life cycle. We're only one custodian of this asset as it evolves over time. All right, so how do you know if you've got a good blockchain use case, or how do you know if blockchain is worth exploring a little bit deeper? Well, if you answered yes to the first three questions and no to the fourth. I'll give you an example. We talked with a trade group, a consortium yesterday in Ecuador, and they're interested in looking at blockchain to manage business processes in the coffee industry. So we had this conversation with them about them. We said, hey, do you have one or more assets you want to track? They said, yes, we want to track the coffee that we're growing. We think this could be a good solution for that. Great. Do you care about the life cycle of that asset? Do you care about being able to tell the story about your coffee? Or do you just need to know the current state? And they said, no, the story is very important. Right now, there's a big push in the coffee world to have organically grown beans and to be able to prove to your consumers that this coffee is all natural and organically grown and not using any chemical pesticides, and it's grown in a way that's environmentally responsible. So yes, for us, being able to tell that full story about how that coffee bean got from the farm to the local market where you're about to buy it, that's critically important to us. All right, well, hey, this process that coffee follows throughout its life cycle, from being grown on the farm to harvested, to being purchased and packaged and delivered to consumers, does all this happen randomly, or is this governed by well-defined rules and processes? And they said, yes, this is very, very clearly governed. We have our own internal business processes. We have rules and regulations at the national level we have to follow. We have rules and regulations that are imposed by various consortiums and trade groups and quality assurance organizations. So all of this is very, very well defined. Okay, well, is there any single voice of truth for questions about coffee along the way? Well, no, everybody who works with coffee is just a custodian in this much larger process. The farmer can only answer questions about coffee during that very first part of its life cycle. The shipper or the importer can answer questions about that coffee in the middle part of its life cycle, but we don't have any participant who can be the single authoritative voice of truth for questions about this asset along the way. So we came up with exactly these answers, 3 yeses and a no. So it starts to look like blockchain may be a good fit. So let's review some of these answers. Again, if you don't have one or more assets that you want to track, you're probably talking about a different kind of business problem. If you have some assets you want to track, this shared immutable ledger of events can add a lot of value. If you care about the evolution or the life cycle of your assets, well, blockchain is going to give you that version history. You're going to be able to tell the story of how something evolved from start to finish, all the different processes it went through, who touched it. You're going to have all that audit information at your disposal. That's the value of something like Fabric. If this information is not valuable, if all you care about is the current state and that historical data doesn't matter, there's a very, very good chance that a database is going to suit your needs and is going to be a lot less complex than blockchain. Hey, if the life cycle of our assets follows this very well-defined process, well, then smart contracts and the ability to automate that process using computer code is likely going to add a lot of value. But really, if you're just looking to capture data, if you're not looking to manage a process, well, then conventional technologies, something like a relational database or a NoSQL database, or even some other emerging tech like IPFS or Amazon's QLDB might be a better fit because you're simply looking to capture data. You're not looking to take action on it. And then finally, are you the single voice of truth? If you own this asset from start to finish, well, then likely a database or some kind of centralized technology is going to be a good fit because you have already established yourself as the centralized authority for any questions about that asset. But if you're just one custodian along the way, if you're only the authority for one particular time window, well, then blockchain's probably a pretty good fit because now we can have this solution built on truly shared infrastructure. We can each contribute our authoritative data to it. And if anyone has any questions, they simply go to the blockchain. They don't have to worry about tracking down the right custodian for that point in time. So some good questions to ask yourself as you're evaluating potential use cases around you. I'll call out a couple good patterns or maybe anti-patterns, mistakes that people fall into. The very first one, and if you're interested in learning more about these, again, check the notes. There's some really good follow-up articles I've included in here. The first one, all else being equal, blockchain does not replace your legacy systems. Blockchain is there to enhance them. That doesn't mean that blockchain can't or that there won't be good use cases for doing so. I'm just saying in general, this is going to be the way that gives you the most value returns. A lot of organizations believe that there's a big future potential in blockchain, but they're nervous to get started because they think that means rebuilding all their legacy systems from the ground up. Blockchain works best if you find an existing legacy system that works, does what it's supposed to do, and adds value, and then you layer blockchain functionality on top of that to get enhanced value from it. So don't tear everything down and rebuild from scratch. Use blockchain to enhance what is already there. And you can think about what kind of opportunities might be available to me if I could take this existing legacy system and plug it into this much bigger ecosystem that I share with all of my other participants in this business network and their internal proprietary or legacy systems. Some other good patterns that you see for using blockchain. Oftentimes there's confusion about blockchain and database. A lot of people see these as competing offerings. One of the biggest criticisms that you'll hear about blockchain is that it's just a poorly performing database. Well, really, this comes from a misunderstanding and not understanding that database and blockchain are two very, very different tools designed to achieve different things. And they don't compete. They very often can work together in concert to do some very unique things. So understand that by design, a database is a solution which is designed to handle storing and retrieving and querying large amounts of data in a very short amount of time. Blockchain is designed to be a logging and transaction processing engine. So if you are looking at blockchain as a primary place to store data, as a data repository, you may not be looking at blockchain in the right way. If you need a place to store large volumes of data and you need to access it quickly, a database is probably the best way to go. However, if you need to be able to tell the story about your data and tell its history and what happened to it and how your data got from its initial state to its current state, then layering blockchain on top of a database can be a really, really good fit. So think of blockchain as the historian and database as the repository. Well, you may go, hey, that's great, but a database is still centralized storage. I need to build a truly decentralized solution. So I need decentralized content storage as well, and a database just isn't going to work for me. Well, no problem. There's some really, really interesting projects going on right now that should be on your radar if you have some of these needs. Things like Storage IO or IPFS, the Interplanetary File System. IPFS is very, very interesting because it is a decentralized content storage protocol. That means you can implement that protocol on any network you want. Just like we implement HTTP as a protocol on the internet and on our private intranets, we can do the same thing with IPFS. So if you need decentralized content storage on private networks, check out ipfs.io, dig into their documentation. I don't want to spend too much time on this. Perhaps we'll do another webinar specifically on IPFS, but there's some very, very cool things you can do with it. Another good use case pattern for blockchain. Persisting state across different applications. This is something that is very, very difficult to do given conventional technology. And in fact, if you go to your AWS dashboard, you can see all of these different solution components that you can deploy into your AWS instance. What you don't see is any option that allows you to maintain or persist state across all of those different applications. This is a very, very difficult thing to do. This becomes especially difficult to do if I want to persist state across applications which cross organizational boundaries. So let's say that you're a manufacturer. You work with Alice. And I'm a reseller of the things you manufacture. So I go out and I land a big sale for 10,000 units of that great new smartphone that you're going to start manufacturing. I close that sale inside my CRM system. How do I communicate that across organizational boundaries into your ERP system so you can start manufacturing the units to fulfill that order? This is one of the biggest challenges we face in IT right now. And distributed databases oftentimes give you absolutely no guarantee that every single transaction will be processed. On many distributed database platforms, you are making the trade-off for performance that not every single transaction is going to get processed. Well, if we're talking about maintaining state, especially if that state is around critical business objects between two different applications which span multiple organizational boundaries, this idea that we may drop a transaction here and there in many use cases is simply unacceptable. So if I've got a safe, shared, secure, immutable ledger that I can draw up my own permissioning on, create my own access rules on, and I can audit access to that ledger, well, this is a great place to start putting some of that state data that I want to pass between applications. And if you come from a more technical background, you might be thinking, if I can share state between applications, I can pretty seamlessly integrate anything between applications, no matter how different or how disparate or how many organizational boundaries I have to cross. And if you're starting to have that thought, congratulations. Now you're really starting to understand some of the really powerful, nuanced solutions behind blockchain. So we've just got a few minutes left. What I've got here at the end of the slide deck are a number of interesting use cases. And in the interest of time, we're not going to go through these all. But down in the notes on each one of these slides, you can find a link to this specific article or press release or announcement. And on some of them, there's some additional supporting information too. So I'll just run through a few of the highlights. The first one here, I think, just speaks to the magnitude of blockchain. This was a report that came out towards the end of last year by the World Trade Organization, who estimated that over the next 10 years or so, blockchain could add an additional $3 trillion in additional trade and commerce. To put that into perspective, $3 trillion is about the annual GDP of the entire country of Germany. So we're talking about over the next 10 years, adding the entire economy of Germany in additional trade and commerce, just because of the effects of one technological platform or suite of technologies. That to me is very, very profound. IBM has a great use case library here. Being IBM, these are all going to be focused on Hyperledger, but if you want to see who's using blockchain in this particular industry or to solve this particular type of problem, you can come in here and browse some of the use cases that IBM maintains. The one I would encourage you to read, if you don't look at any other use cases, take a look at this very short white paper that Hyperledger wrote about a solution they did with the National Association of Realtors. National Association of Realtors is a trade group in the United States that is made up of over 1,200 different fully independent member organizations. NAR wanted to collect some data about individual real estate agents. Everyone loved the idea. Technically, they could have done what they wanted to do in a database. There was only one problem. And that was trying to get 1,200 CEOs to all collectively agree to give up ownership of their data and place it into a centralized system that they don't own, control, or administer. That was a non-starter. And they were able to use Fabric to solve this problem. And I think this is a problem that pretty much all of us universally face somewhere in our business. Hey, we're all on board on an idea. We have multiple organizations that want to pursue it, but no one organization should own the idea or the infrastructure. How do we do that on something like Hyperledger where that infrastructure is truly shared? Definitely a good white paper to take a look at. There's some articles in here about blockchain in the food supply chain. Including this one that Walmart has told all of their leafy green produce suppliers they have until September this year to be on the blockchain. There's an interesting article I put in the notes on this slide that talks about how Walmart forcing all of its suppliers 12 years ago to use RFID tags ended up making that a common standard in retail. One has to wonder, is history going to repeat itself if Walmart forces all its suppliers to start using blockchain? Does that become the new standard in retail? IBM and Maersk working on a solution called TradeLens for the shipping industry. In initial testing, they have been able to cut the time it takes for a shipment to make it across the ocean by 40%. You can read more about how they were able to do that in this press release. Some big names making investments into this technology. Groups like Mercedes-Benz, FedEx, Air France, Singapore Air. You can read all about what they're doing with blockchain and some of their initiatives. If you want to see what's happening with blockchain in the public sector, you can look at the Smart Dubai initiative, an initiative to move all government record keeping and operations for the city of Dubai onto blockchain by the year 2021. Very large, very ambitious project, and they're making some incredible progress towards that goal. My City, a startup in Dubai using blockchain to offer secure access solutions. They've got some very interesting stories that speak to some of the efficiency gains. So just by using secure access solutions in kiosks, in buildings, they've been able to save organizations up to $15 million per year. Of course, the UAE is not the only area where blockchain is being looked at in the public sector. A big part of Saudi Vision 2030, the push to modernize and reform the economy of Saudi Arabia over the next 11 years includes blockchain. You can read about what IBM and the city of Riyadh are doing to explore this technology in the Kingdom of Saudi Arabia. Finally, if you're looking for a good blockchain project to get started with, and you think you can build out a solution for $150 million or less, the good folks at Kerrygold Butter may want to talk to you. They're facing a class action lawsuit in the state of California right now because they don't have a way to prove their claim that all of their butter is made with milk that comes only from grass-fed cows. So they're facing a class action lawsuit to the tune of about $150 million. Definitely a group that, if they had a blockchain solution, could probably make this an open and shut case. And then finally, I'll just leave you guys. I thought this was a very interesting closing thought by Kris Giancarlo, the outgoing chairman and commissioner of the US CFTC, just talking about some of the potential that blockchain offers, and I think some of the amazing transformative change that it's going to have in our world. So I want to thank you guys for joining us. Let's see, we did get a couple questions, so I know we're a little bit over time. I'll answer a couple of these real quick. Of course, if you guys have questions that we didn't get to, or you want to talk more about blockchain, be sure to visit us. Check us out at Blockchain Training Alliance. Start up a chat with us. Those are always managed by real human beings, not robots or some AI. And we'd love to talk to you about blockchain, how we can help you, what classes might help support you. Well, let's see, we got some good questions here. So the first one, in this type of channelized ledger, the new blocks are created where in the channels or in the main ledger? Great question. So in that channelized approach, remember, every channel has its own ledger. So when we create a new block, it's going to be created on the ledger in that channel. If we feed information out to another channel, well, then we're just creating a new channel, or I'm sorry, a new block on the ledger that lives in that channel. Again, if you want to know more about that architecture, check out some of the links in the notes on those slides, and you can dive deep into some of the official documentation and really learn about block creation and how some of this is happening. Let's see, in peer-to-peer, all nodes are peers and have the same data. Why should any node request information from a peer? Well, in peer-to-peer, all the nodes have to make sure they're staying in sync with each other. So it's not just enough to have my copy of the ledger. I need to periodically ask you what's on your copy so I can make sure we have the same thing. So this is very often why nodes are requesting information from each other, is simply as a part of this consensus process. But very, very good question. And again, check out the notes and you can learn at a deep technical level how all this is working on Hyperledger and what makes it a little bit unique from a traditional peer-to-peer deployment. Oh, here's a good one. I'm glad this question came up. Hey, I'm new to blockchain. How should I start learning? What do I need to know? And I love this question because if we go back to the very beginning of this slide deck, right here when we talk about basic blockchain terms on slide number 3, check out the notes on this slide if you want to learn more. I've got some links in there, including links to 2 absolutely 100% free classes. The first one is a class we offer called the Business Foundations class. Sign up, 100% free. That is designed to be a very non-technical introductory overview of blockchain. The second free class you can take is one that we partnered up with the Linux Foundation to create, another great introductory blockchain class featuring myself and some other instructors we have at the Blockchain Training Alliance. So between those two, you can find some great links to get started. Again, they're right here on the notes of slide 3 where we call out these basic blockchain terms. All right, and then last but not least, let's see, since each Hyperledger project brings its own strengths, can all these coexist and interoperate in a single use case? I imagine the Hyperledger projects you're talking about are the official, if you go to hyperledger.org/projects. It's a really, really good question. If you go take a look at some of those projects, you'll see many of them are designed to interoperate. Some of them are competing offerings. So for example, 2 of the projects that you'll see listed there are Hyperledger Fabric and Hyperledger Sawtooth. Fabric and Sawtooth you can think of as being the operating system of a Hyperledger environment. So if I decide to go with Fabric, I can't use Sawtooth. If I decide to go with Sawtooth, I can't use Fabric. But many of the other tool sets, such as Composer or Explorer or Caliper or Aries, are designed to run on either Fabric or Sawtooth. So if you're wondering more about how these projects fit together, take a look at hyperledger.org/projects because the answer is actually a mix of both. Not all of them play together. Some are mutually exclusive. Others are designed to plug into just about any other project. With over 13 different projects talking about all the different combinations and permutations can get a little bit complex. So take a look at hyperledger.org/projects. You can learn all about those. All right, so I know we went a little bit over. If you stayed with us the whole time, thank you so much. I think we had some really good questions here at the end. Like I said, many of these use cases at the end, we just got a chance to skim over. If you want to learn more about who's using blockchain, what they're doing with it, some of the value they're getting out of it, and how you might use it, take a run through some of these use cases. And again, feel free to reach out anytime, ask any questions. We're always here to help support you, point you in the right direction for education needs and to help get you supported and started as you work to make your blockchain dreams a reality. So thanks everyone again for joining us this morning, this afternoon, this evening, wherever you're at. It's been my pleasure sharing all this information with you, and I hope you're able to join us next time we do one of these webinars.
There's a crazy amount of information being put out about blockchain on a daily basis.
But when it comes to blockchain education and certification, Blockchain Training Alliance has become the clearly trusted source for individuals and organizations.
With all that noise out there, it can be pretty tough to understand this technology or the implications it might have on your business.
The source for detailed and comprehensive knowledge.
Most trusted vendor neutral certification.
Crisp and clear with explanations.
Thank you to Lee who provided this review. I found it to be more informative on blockchain technology than some other online courses I've taken. The video format was great and easy listening. Thanks for sending that over.
And here's a review from Mr. Olufemi. This is the best blockchain course out there. It was put together in a very easy and relatable format that anybody can understand. Thank you guys for such a wonderful job. Thank you for that review.
And Anthony Day from Deloitte says, Blockchain Training Alliance are the clear leaders in the training space, and thanks to the whole team for your hard work that's helping the Deloitte blockchain teams worldwide to bring new value and exciting blockchain propositions to our clients and consortia. Thanks for that, Anthony.
And here's another one from Subhadeep. When I started the course, I just had the knowledge of the word blockchain. And after completing this course, I am now well acquainted with the technology and can explore more areas for implementing blockchain as a solution. So in a single word, this course is just awesome. Thank you, Subhadeep.
The best part is, these quotes are based on real customer reviews.
Thank you.
Thank you.
Thank you.
Thank you. Thank you.
From all of us to all of you, thank you.
Thank you for making BTA #1 in blockchain education and certification. We couldn't have done it without you.
Thank you. That's perfect.
Welcome to Blockchain Training Alliance. Looking to learn more about blockchain? At Blockchain Training Alliance, we can help with all your blockchain or emerging tech needs. Come on in. We have training, certifications, and workshops for both technical and non-technical audiences. We offer 1-day, 3-day, or 5-day trainings. Need help with a use case exploration? Or perhaps your organization needs help with a proof of concept built out? All of our trainings, workshops, and certifications have been specifically designed with organizations and enterprises in mind. Just getting started with blockchain? No problem. Check out our free on-demand Blockchain Foundations course. You can learn live in person, we can come to you, or you can learn live on demand. We have a number of on-demand courses, including data science and blockchain, healthcare and blockchain, blockchain security, and more. For technical audiences, we have both on-demand and live training on Hyperledger, Ethereum, and Corda. Looking to get certified? We are based in the United States, but our certifications are offered globally at over 7,000 Pearson VUE testing centers. Our exams and content have been vetted by our exam advisory board that you can view on our website. Please visit blockchaintrainingalliance.com to learn more.
Hi, I'm Tommy Cooksey. In this course, we're going to be taking a look at healthcare in the blockchain industry. We're going to be looking at how the blockchain industry can face lots of different obstacles by utilizing the tools that are available within the blockchain toolbox. We're going to be looking at how lots of different problems with regulation and compliance can be addressed by using blockchain solutions. We'll be looking at things like GDPR compliance, HIPAA regulations, 21 CFR Part 11 compliance, and USDCA compliance. We'll be looking at Web 3.0 technologies such as IoT, AI, and how those technologies along with blockchain and smart contracts can help to provide solutions for an entire well-rounded healthcare environment.
Blockchain Training Alliance. And welcome to our Hyperledger Fabric Composer Developer on Demand course.
Data Science and Blockchain course from Blockchain Training Alliance. I'm Luciano Pesci and I'll be your instructor.
My name is Peter Thorstensen and I'd like to welcome you to this course from Blockchain Training Alliance.
We're here to study blockchain and healthcare. I'm Tommy Cooksey and I will be your instructor through this training.
You want to become an Ethereum blockchain developer?
Welcome to the Blockchain Training Alliance's course on blockchain architecture.
To understand the
My name is
basics
Kris
of
Bennett.
blockchain.
I'll be your instructor. Blockchain Business Fundamentals course from Blockchain Training Alliance. My name is Kris Bennett.
Introduction to Blockchain Security course. I'll be your instructor today. My name is Howard Poston.
Are you interested in learning more about blockchain or becoming blockchain certified? That's where we come in. We are Blockchain Training Alliance, the global leader in blockchain training and certification. We offer training courses in a number of ways. Live in person, either on-site at your location, or at one of our classrooms worldwide. Live, virtually, via WebEx, or self-paced. If you are looking to verify and validate your knowledge, we have 4 certification exams that are proctored in person at more than 7,000 testing centers across the globe. We have one-day business foundation courses. And if that's not deep enough for you, we have a 3-day blockchain solution architect course. For developers, we have hands-on Ethereum and Hyperledger courses. Our training includes expert instructors, hands-on labs, real-world applications, a course book, an official study guide, and 1 free exam voucher. We have trained thousands of students worldwide and have professionals becoming certified every day. Visit Blockchain Training Alliance to learn more about our blockchain training and certification programs. There's a new technology that has the power to revolutionize how you, businesses.
When you hear about blockchain, you probably think of new, high emerging tech.
Let's start by understanding why we even need to have an identity on the blockchain.
It's really important to have blanking, but it's also important to be able to have share weighted.
When a transaction is conducted, it's posted across tens of thousands of computers.
Permissionless blockchains. We can talk about some of the differences and what each different type of blockchain.
This allows blockchain to serve as a truly reliable storage of public records and transactions. We all carry the internet in our pocket. We can transfer money at the touch of a button. So now, in this exciting time in history, every kind of asset from
in traditional cybersecurity that we're all used to, we're very perimeter.
Let's go ahead and define that. Let's talk about what blockchain is. And as you start to get involved in blockchain, what are the first...
Hi guys, it's Ken with the Blockchain Training Alliance, and I'm here to tell you about some major developments that we made in Hyperledger Fabric. We've written a lab guide that teaches you how to go from zero to hero using composer development. This teaches you how to write model files, create transaction processors, write permissions files, and also queries. We don't stop there. We teach you how to package up the business network and deploy it to a REST server. And then we teach you how to secure it using OAuth. And at the very end, we tell you to throw everything away, and we give you a capstone project on how to create a business network from scratch. So if you're interested, go ahead and click the button below.
Are you looking to become a certified blockchain solution architect, but you just can't attend one of Blockchain Training Alliance's live 3-day trainings? We have great news for you. Blockchain Solution Architect training is now available on demand. No matter where you are in the world, you can now learn on your own time, at your own pace. This self-paced course is taught by BTA's Chief Learning Officer and lead instructor, Kris Bennett.
Hello and welcome to the Blockchain Training Alliance's course on blockchain architecture. My name is Kris Bennett. I'll be your instructor. Over the coming hours, we're going to start from the very basics of blockchain and walk you through everything you need to know to start identifying good use cases in the world around you and building compelling blockchain solutions.
With 60 days of access, a course study guide, an exam voucher, all included, our on-demand package is all you need to get certified. Enroll today by visiting blockchaintrainingalliance.com.